Assalamualaikum and welcome back. In this video, we will continue discuss the solution for the structural question for topic 11, which is about the deformation of solid. We will continue with question number 6. An object of mass 6 times 10 power of 3 kg is suspended from a steel cable of length 50 meter and cross-section area 2 times 10 power of -4 meter square. We need to determine the extension of the cable when the mesh cable system at rest. When the system is at rest, the tension in the cable is equal to mg. So this tension represents the force exerted in the cable. When we substitute in the equation of Young modulus, we can calculate the extension of the cable, which is equal to 7.36 times 10 power of -2 meter. For question number 6b, we need to determine the extension of the cable when the mesh cable system moves upward at a constant speed. Since the system moves with a constant speed where the acceleration is equal to 0, the tension is equal to mg. Because of that, the value for the extension is same as in calculated in A, which is equal to 7.36 times 10 power of -2 meter. For question number 6c, we need to determine the extension of the cable when the mesh cable system moves upward at a constant acceleration, which is 2 meter per second square. So we need to use the Newton's law, where we have that the T minus mg is equal to ma, and T is represent the force in the cable is equal to 70.86 kilonewton. And when we substitute the T as the force inside the Young modulus equation, we can calculate the extension, which is equal to 8.86 times 10 power of -2 meter. Question number 7. A metal rod of 10 mm diameter and 30 cm length is stretched by a forces of various magnitude. Stress against strain graph of the wire is as shown in the figure 11.4. We need to calculate the Young modulus for the metal of the rod and the extension if the strain in the rod is 0.05. Referring to the graph given and the information from the question, we can calculate the Young modulus by using the equation of stress over strain. When we substitute, we get the Young modulus, which is equal to 4 times 10 power of 9 Pascal. For the extension, if the strain in the rod is 0.05, we use the strain equation, we substitute the value, and we get the extension, which is equal to 0.015 meter. For question number 8, a metal bar that has a cross-section area of 4 cm square and length of 50 cm is stretched by a force of 1 times 10 power of 4 Newton. For question number 8a, we need to find the stress on the wire. So referring to the given information from the question, we can calculate the stress of the wire by using the equation of F over A. We substitute the value and we get that the stress is equal to 2.5 times 10 power of 7 Newton per meter square. For question number 8b, if the bar elongate by 0.5 cm, what is the strain in the wire? So to calculate the strain, we use the equation of strain, which is elongation over inertial length, and you will get the strain, which is equal to 0.01. For question number 8c, we need to determine the Young modulus of the wire. Because of in A and B, we have calculated the stress and the strain of the wire. So we just use that value to calculate the Young modulus. Because of that, we get the value for the Young modulus, which is equal to 2.5 times 10 power of 9 Newton per meter square. And lastly, for question number 8d, we need to calculate the strain energy per unit volume stored in the wire. So we use the equation of strain energy per unit volume, which is equal to half stress times strain. So we substitute the stress and strain calculated in A and B. We get the strain energy per unit volume stored in the wire, which is equal to 1.25 times 10 power of 5 joule per meter cube. For question number 9, a wire has a mass of 5.3 gram and length 2.5 meter. A force of 50 Newton can extend the wire by 2.3 millimeter. So for A, we need to determine the Young modulus for the metal of the wire, and B, we need to calculate the strain energy stored in the wire. From the information given, include the density of the metal wire, we can calculate the cross-section area of the wire, where we will use this value to substitute in the Young modulus equation. Then we can calculate the Young modulus equation by substituting other value. We get the Young modulus, which is equal to 6.92 times 10 power of 10 Newton per meter square. For the strain energy stored in the wire, we use equation of half Fe, and we substitute the value for force and the elongation of the wire or extension of the wire. We will get the value for the strain energy, which is equal to 5.75 times 10 power of negative 2 joule. For question number 10, stress against strain graph of the wire is as shown in the figure 11.5. What are the parameters represented by the Young modulus and strain energy per unit volume from the graph, and calculate their values? Referring to the graph, the Young modulus is represented by the gradient of the graph. Because of that, we can calculate the Young modulus, which is equal to 2 times 10 power of 9 Newton per meter square. For the strain energy per unit volume, it is represent the area under the graph, and when we calculate the area under the graph of stress versus strain, we get the value, which is 6.4 times 10 power of 6 joule per meter cube, which represent the strain energy per unit volume. Please show your support by clicking button subscribe, like and share, and leave a comment so that I can improve and can produce more video next time. Thank you. Thank you for watching, and I wish you all the best. See you.